Good morning. Good morning, everyone. Welcome to Stream 2. I hope you had a lovely morning tea. It's our pleasure to introduce you to our first speaker in this stream. His name is Igor Costa. He comes to Wellington via Brazil. He's been here for a year and a half or so. He's been working at Solnet as a solutions architect. And previously to that, he was a senior UI developer at View Explorer. So today, Igor is going to be talking to us about deep learning in our browser. So please join me in welcoming Igor to the stage.
Cool. Is it working? I think, yeah, cool. Everyone is listening to me now? Okay, all good. Hi, everyone. Thank you for attending the conference today and being here to listen a little bit of Brazil English. And I hope I can fulfill your needs on some of the deep learning understanding. How many of you have heard about deep learning and UI stuff and AI, right? Most of the audience, that's cool. So let's say, kia ora. I'm a solution architect from Solnet, right? And I'm also a product manager committer for Apache Foundation. Generally speaking, I help and produce some of the most challenging projects out there for deep learning, which is Apache Spark, Apache Kafka, and many others, right? And I'm living here in Wellington for 1.5 years, like Kirk said. And you can check out me at Igor Costa in GitHub or Twitter. And you can drop me an email if you want to after the presentation. It's totally, you feel free to do it. So what is AI? When we understand AI, we understand that it's just like artificial intelligence, that out of the blue, some machine will kill you or steal your job or just like do a preparation meal cook for you. None of that. We are so far from that thing in reality, right? So AI, in a simple sentence, to make sure that you guys get the message, it's just like an algorithm that do things that indistinguishably will be the same as a human being doing, or a bunch of slaves locked in a room doing the same kind of work, like, for example, Amazon product reviews, right? So instead of doing that, you can do it with an algorithm, right? And we are very far behind from this thing. We are not even close to that. If you take a look at really precisely to this gift, you're going to see the box with a QR code, right? And then this is a dumb machine trying to imitate a human being. But the problem is, this machine needs to understand the environment around it. It doesn't have a self-distinct awareness, a context awareness as a human being. If you were a human, you are not doing a pathetic movement like this, like waiting someone to put a stick on your chest, right? You could avoid it, right? So, right, it is scary, it is. It is something that in the future might be happening, that a machine will kill like Skynet in the movies. I don't think so. We are very far from that, and we are still in the cornerstones of the AI. And then in this presentation, I wanted to share with you guys what this is all about. So this thing is just like a 10 years research, right? So AI is just 10 years stuff. We've been researching, we've been learning from the past 50 years as a human beings, as a human species, trying to understand how we can teach our knowledge and transfer our knowledge like we do with our kids. Hey kid, don't put your finger in your nose, right? Something like that. But we are trying to do the same with machines. But it's in the very early stages, and then I believe none of us will be here in this world when that happens. So in a much humbler sense, machine learning or deep learning or AI is just like something out of Netflix. When you watch a movie in Netflix, it will recommend you another movie. Say, oh, based on your user's profile and based on your friends, someone with your same profile or same persona already watched this movie as well. Do you want to watch? And then as soon as you click, the algorithm will reevaluate and recommend another movie for you. It's on the stream. Every time that you update Facebook with your silly questions or with your beautiful photos of naked cats, right? Just kidding. You are teaching an algorithm to understand that movie or to understand that picture, and then you are helping that. And then if you take a look of this perspective as a developer, everything is happening on the client side. None of that is happening on the back-end side. And then I'll explain to you this later. When you see driverless cars, right, there are 3 levels of driverless cars. What I mean by that, there's a assisted car driver. We've been using that. Who owns a BMW from the 80s already know that you can have a steering wheel car that will not move lanes without you asking for. But this is the first level of driverless cars. The second level is what Tesla is trying to achieve. Is steering your car to pass to another lane, right? And don't kill any deer. That's the problem. That's the problem they are trying to solve. Or not hit your car on the backs of other people's car. So we are in this second level. And the third and most important level is we don't have that yet in cars, but we have in rockets. So some company in New Zealand also is doing that, which is telemetry data. It's kind of like creating something in a 3-dimensional space that you can see the context awareness. So you can see everything around you, not just a static object or objects that needs to move, like persons, like pedestrians, like cars, like cyclists, all of that. But we don't have that yet. That's why we have to train, and then we have to relay in a humongous amount of data to be able to achieve that. And then we have to map. There's a company called LiDAR from Israel that is doing that in the US. So what they did was they hired 1,000 people to drive the cars to map all the roads. Otherwise, the machine will not be able to drive by itself. Again, if we come back to the previous slide, you see that we still need to be the context. The machine needs to know where it is. Otherwise, it will not properly behave like you expect it to. So we have drones like DJI 4 Pro with, or DJI Mavic with object collision detection, right? We have natural language processing like Google Translator. Every time that you use a Google Translator like me, I'm helping the algorithm to reevaluate sentences, right? Previously, when Google bought the company that created the first Google Translator, they had one of the most sophisticated translators in the world. Why? Because they put someone seated 8 hours a day just doing mapping stuff with irregular expressions or regular expressions from English to French and from French to English. And then they achieve a very bunch of data on that matter, but sometimes someone, for example, basically in Brazil, it's very common that you use Google Translate to do your preface work for publishing your letters for the college, right? And then sometimes doesn't make sense at all. But what Google did, and then it was just like a month ago, they released a new deep learning algorithm to be able to understand what people are saying. Why? Because every time that you say, hey Google, or hey Siri, they are recording your data, and they are trying, or even Siri is trying to listen to me. They are recording your voice, and they are trying to understand what you are saying, right? Because they need to know as many data as they need to be able to understand what you are talking to. So we have predictive analysis like forecasting or something like that. We need image recognition, like we have millions of YouTube videos, and then we wanted to identify which one a cat appears, right? And then it will classify that for us. Speech recognition, like I mentioned, when you work with Siri or Google now, right? AI, you just imagine AI as a tree. I like to do this comparing stuff. AI is just a tree with a bunch of branches, And then one of them is machine learning, the other one of them is deep learning, and so on. We have so many. We are even talking about deep forest networks, which is a much more complex, without labeled data, to be able to understand. It seems a little bit complicated, deep learning, but actually is not. If you take a look at the perspective of a developer, it's just an if-else stuff, but in a much larger situation, right? And then AI is just a symphony of buzzwords talking about the same matter. So let's say you want to learn what is machine learning. Instead of writing thousands of switch cases or if-elses or all of that stuff, to be able to comprehensive the data that you are trying to parse or trying to render from your user or collect that data, you just simply say, my algorithm, based on a selection of the criteria, I will try to understand what my user is trying to say or trying to input. And then I will give you a score based on the distance, right, from 0 to 1. It doesn't go much longer than this, right? Let's say I wanted to analyze the sentiment of people saying stuff in Twitter. How do I do that? I use a sentiment analysis. The sentiment analysis is pretty simple. I train my data. I train other data from other data sets available in the internet. I extract some features. I will put some stop words like depressed or fuck up, sorry for the word, or I'm sad, and then I will say, this is a sad behavior, this is a sad sentiment. And then I will increase my model, and then I will be training my model, I will try to evaluate the data that I have, and suddenly I have a nice score. So when you say, for example, the sentimental, which is a Node.js package that analyzes the data, it's much more simpler to validate all of that without even requesting my database or my SQL query to analyze what the user is trying to say. I just score. So in between, if it is negative enough, I would say, yeah, this thing is not positive, or I just accept positive comments on my applications. You can do this easily. Let's say recommendation, right? You wanna create a recommendation system. You want to create a machine learning for your products. For example, e-commerce, right? People who bought this product may bought this one. We can do this with the recommendation, which is a like package. There's already implemented in JavaScript. You can also cluster. What I mean by that, let's say you are pretty lazy. We are as a developer, right? We try to automate everything that we do every single day, and then we try to summarize. So who deals with website with news? We just go to Hacker News, right? And then you just see the title of the article, and then we are just like summarizing everything that we want to learn. Clustering is another stuff. Let's say you have a big sentence, or you are trying to create a document management system, and you wanted to summarize that document to your user. So, and then you can give him the perspective of saying, this document you are searching for, it's right here, because we summarized the text for you. And then there's a bunch more. How many algorithms already is available to the internet or to anyone out there? I think it's around 187. It's a lot. And all of them are very specific to specific problems. Remember the context awareness? Machine doesn't know where it is. We need to teach them how to do it. So Talisman is a Node.js package that have half of that number in algorithms already implemented in JavaScript. So you don't need to implement by yourself. You don't need to be a mathematician, right? It's already there. You just need to use the API for it. So, and then we keep up with the deep learning. So what is deep learning? Deep learning is just a branch of machine learning that mimics the human neuron and with a high level of data. Let's say, instead of analyzing half a dozen inputs, we can analyze 20 million inputs. We can analyze billions or petabyte of data to be able to understand that. And then we can put a video or an image, and then we classify that image to understand if it is a flower, if it is a dog, or if it is a car, or if it is a pedestrian, right? And vice versa. Let's say this is, for example, a playground for TensorFlow. Let me show you guys how this works. It really mimics the way the brain behaves. Let's say you have a bunch of data here, and then you want to, for example, understand how the classification of a movie or how the classification of a data is happening, right? There are one single layer of the neuron. Let's say you have only one neuron in your brain right now, which is almost impossible, right? And then it tries to understand what the data is telling you about. And then the learning curve, and then you are training this on your machine, on your GPU desktop, right? And then it tries to understand you. Instead of just doing a curve to filter all of the data, you just include new hidden layers. And then on top of that hidden layers, you create even more. And then as much time, you decide if you wanted to prioritize the learning experience or the time. If you prioritize the learning experience, you're going to reduce the time to learn, because you don't teach kids grammar in the first day they're born, right? You have to wait them to be able to talk with the parents, and then you put him in a college or in a school, right? And then if you have no brain at all, you can do anything, right? But let's say I wanted to include 2 hidden layers and 5 neurons, right? And then I wanted to fix it. And then automatically, my data, based on the users playing this playground, is be able to fix all of that issue of filtering, classifying that data for you. So you don't need to do any more if-else stuff. You just need to train your data to be able to understand that. Instead of doing a complex select with a lot of in and joins, you're just doing a deep learning stuff to be able to do that for you, right? Like simulating the brain selection. So in a very emblematic and simple sentence, something like this. Imagine that you have a photo of a flower, right? And then you split that flower in pixels, and then you are just saying, you're going to label this flower as a labeled data, say, this is a photo of a flower. And then it will split up all that data for you in pixels in matrix of 1 and zeros, right? And then it is going to train all that data for you to be able to understand if there's any other similarities of that flowers on your data set, and then we'll create a model set of that. And then it will try to softmax the distance between the pixels of each image, and then we'll come up with an output for you, right? And then we'll come up with a probability. Let's say Donald Trump, right? Donald Trump got into a machine learning or a deep learning algorithm, and then we need to understand what he's saying, or just a picture of him. We're going to split the pictures of him, and then we're going to put the value, the maximums of the data represented that picture because we label as a Donald Trump, and the output should be you fired, or the wall, right? That's the beauty of deep learning. You don't come up with just 0 and 1. You came out with cognitive results or with complex data output, right? So one of the APIs already available to be able to do that with your software, for example, you wanted to detect nudity, right? You wanted to filter the nudity. You can just use Microsoft Cognitive Vision API or Google Vision API, and you don't need to implement a wrapper because someone already did that, right? Like they said, there's an app for that. There's a node package for that as well. Or you can do live. So it's not just image. You can do also in a live video. For example, this is YOLO. YOLO is a very well-known project that works with OpenCV, very early stages, like I think it's in the 96, for example. OpenCV was there already available. And then he just integrated deep learning to understand based on the image that captured for every single frame. And then he created a data based on an ImageNet that Google gave us for free, which is like 40 million records labeled data to be able to understand the objects and detect objects. And then this is a very good example of helping impaired people to navigate to the city. We are trying to solve cars, but we're not helping people to cross the street, right? Which is a shame. Let me show you guys the example. Yeah, detects automatically the car. So it doesn't only detect object transitioning in static mode, but also in a live mode. So you can do that with JavaScript as well. There's a wrapper for YOLO as well, so you don't need to write anything from scratch, right? It detects people, detects animal, even play matches. So how an algorithm in deep learning works, right? Let's say you have to have a GPU and a cluster, right? If you are rich enough, you can afford a big expensive GPU that will work for you, right? Because why CPU is not the most advised one to teach your data or train your data? Because it's limited. You only have 4 cores, or you have only 8 virtual cores, right? GPU eliminate that bottleneck, right? So let's say the numerical operations that you are available on a GPU, it's humongous. It can be 100 times faster than a CPU when you are training locally with your one single machine. But the problem is a very constraint on the memory. You have a limited amount of memory to be able to work your data, especially if you have a big volume of data. But if you have a small data and you want to train a specific algorithm to train that, for example, sorting cucumbers, right? Like a Japanese guy did. He just did that with a single machine. It's fine. But let's say you split the task and you wanted to analyze the images, and then you're going to work with your GPUs, right? And then you pick the best model out of that. And then you are training and then creating new models on top of the pre-existent data. For example, Netflix style, right? But the problem is, you have a big volume of data. You have to cluster. You have to split the workers among the network. You have big networks of data centers, or you just like hire Google Cloud or any cloud system, AWS, but it's expensive. And then the problem is, it's too much complicated. You have to learn a lot of stuff to be able to do that, right? And it's too expensive, even in the cloud world. But the best benefit is can understand and then can support billions of data, right? But what about, so for example, most of the popular tool sets, TensorFlow, Café, Keras, and Theano. Those of the top deep learning frameworks doesn't use JavaScript. They mostly use Python, Scala, and R, and Julia sometimes. And most of the frameworks already there use this programming language. How many of you here knows Python? Whoa, that's good. So half of you guys can do deep learning stuff with TensorFlow, right? Let's say, how hard is to master deep learning? My time is, that's why I'm jumping slides. How hard is to master deep learning right now? As soon as you get out of here, you can learn. It's pretty simple. You can learn deep learning without a PhD degree in 2.5 hours video. This guy, yes, it's true. I'm not kidding. You can learn pretty quickly how to apply deep learning in your work, easily, right? So, but I keep wondering, what if I could just use JavaScript to teach my browser to be able to understand all of that without even changing my mindset in a new program language, right? We have these 3 frameworks called ConvNet.js, MindJet, and Synaptic. All of them try to do a KAN network or CNN network, which is understand simple problem classifications, which is awesome, because most of the problem in deep learning is on that area, right? But why JavaScript? Why? Because it doesn't have too much power, right? Actually, sometimes TensorFlow is much slower than JavaScript in the browser. Why that? Because in your browser and in your JavaScript, you can access the GPU, don't you? Why don't you just split that and then put the workload, instead of going to the backend, you put your customer to render or to parse the data for you. And then ConvNet.js help you to do that. Thank you.
Okay, thanks, Igor. We've got
pleasure.
5 minutes for questions from the audience. We'll bring our microphone round so that the questions can be heard by everyone.
I think the audience is shy, or
Come on, that was an awesome talk. There
my
has to be
my
so
my
many
my
cool
talk
things
was not
about
good. Yeah. Oh, good.
it. Okay, we've got a tentative one back here.
Have you, would you have an example of where you've used this within your work at some point?
Yeah. Yeah. Pretty much.
Could you describe one briefly?
So you are asking if I can share some of my work example, right?
Well, just like just a context, not like
Yeah.
a technical example, but just a description, like a use case where you've used this.
Yeah. Let's say you can access this gallery here. There's a lot of example. Sorry about that. There's a lot of resources available for you that you can dig into it, right? One of the coolest example that you can find about deep learning and the applied, for example, teaching the algorithm to understand what you are saying without the audio, just the lips movement, right? This is one of the works that I've been working for as well. Yeah. It's here, right? And the other one is like face-to-face recognition. I don't think it's here, but you can find on my GitHub. It's face-to-face recognition. Right. Oh, yeah? Yeah, there you go. Face-to-face recognition. And then try to mimic the lips of your movements and try to put Vladimir Putin to say some words in English as well. Yeah. And many more. Some of my work in the deep learning I've done for just hobby, classifying images of pictures in Instagram with the images of flowers here in New Zealand. So it's available also in GitHub as well.
I think there's a question somewhere up here.
Just wondering if you were, have done anything, you're talking about like AWS and clusters and stuff like that. Have you used anything like Lambda or anything like that to try push out any of that computation at all? Or?
Nah. We are a pretty small country, right? Yeah, I mean, there's some challenges back in Brazil, but let's say, for example, I will disclose some of the information of my previous employee back in Brazil. We had a very big problem is trying to understand people when they search for products. It's a retail company, and we try to understand like you do with Google now, and then you basically, we had access to 2 petabytes of data, so we could create a very large model of that. But in New Zealand, the most advanced data model that I have heard of it is just like 5 giga. It's different. Yeah. I think, is that the question, isn't it? Yeah, cool.
Okay, we're actually out of time now. Please join me in thanking Igor for his great talk.
Thanks, guys.
Cool. As you know, there's 2 streams, and you've got 5 minutes to jump between them. In this room is